So I'm Patrick Dudas. I'll be talking today about D3 visualization in the net. Just to give a little background on who I am, I leave this blank on purpose because I know who I am. So I already mentioned, I officially am a doctoral candidate at the University of Pittsburgh. I study visualizations in social media. I've been doing visualizations of specifically using SVG for about the last 6 to 7 years now, various projects. I worked in clinical pharmacology, I've done work with the government in terms of social media, civil engineering and different types of that. So I've looked at a lot of different data sets, usually it's larger data sets, and try to make sense out of that using visualizations. So this is where I unplug my own visualization meetup group real quick. Sorry about this. So I run a data visualization meetup group. If you're interested, check out Meetup on the Meetup. It's the Meetup website. We look at things like art, data, UI, UX, and coding, and looking at integrating that all together. I also want to mention this. If I talk about any code today, or if I used any code within my past meetups, and you're interested in looking at it, check out Dudas PM, the Pittsburgh Data Visualization Group, which basically has all the code there that I'll be talking about today. So you don't have to sit there and write down all this stuff as we go. So there's this idea that's kind of a counterintuitive motion that was going on back in the 40s, 50s, and 60s about this idea between artificial intelligence and this intelligence amplification. The artificial intelligence, everybody knows about. Take intelligence and try to mimic human behavior of some sort. But there's also this idea that people were trying to do this idea of taking computers and man and try to kind of put them together and have them work together in a sort of a coherent sort of adaptation sort of way. And that's where I think visualizations come into play a lot of times, because you're trying to make data accessible to every and all people. Specifically, if you're looking at experts and how they're using it, how to actually make this accessible to them by giving them some sort of presentation that makes sense to them. The idea of the visualization idea is that you probably know this already, but you try to take information from your variety of different sources that are available out there, and this is where the exploratory analysis part comes in. This is the visualization aspect of things. Take that information and plot it to some sort of, put it on a plot, put it into a diagram, put it into some sort of way to actually mimic the data and represent it in this way that's fair, but also in a lot of ways, a lot of the visualizations I work with, try to make them interactive and dynamic as well, so they can actually be utilized maybe in real time or have this ability to be changed and manipulated by the user themselves. And things like, the pattern discovery, stuff like that comes out of this sort of new knowledge discovery aspect. Before I go any farther, I get this question a lot. What actually is a visualization? I'm going to give you my definition because there's not actually one clear definition of this. For me, first off, there's things called infographics. Infographics, to me, are static. They're a representation of somebody taking data and applying it to something that looks kind of pretty and giving it to the public for them to kind of, read and sort of, understand at that given point. A lot of times, this type of information is already sort of, they already have an idea of what they want to talk about, and they're trying to push that message to that individual. There's an idea called modeling. Modeling is this idea that you're taking a real-life system and trying to mimic it in some sort of visual form. This wonderful project called Folded, if you've never seen it before, it's out of the University of Washington. They made a game out of looking at protein-protein interactions, and because of this game, they've actually found out a lot of interesting kind of new sciences when it comes to DNA and protein structures. Finally, visualizations. This is where I think I find my domain more or less, is the idea of just taking data and sort of letting some sort of front end sort of represent it in some sort of way or fashion. This can be some sort of a way to actually have the interaction, allow somebody to look at the data and just interpret it in their own sort of understandings. So I also like to talk about this idea of when graphics and visualizations can go bad. As if you maybe remember that time period, on January 28th, 1986, we had the Challenger, which had exploded. The issue, if you don't happen to remember, was that the fact that there was an issue with one of the O-rings, which was attached to one of the rockets, and it ended up exploding and causing the Challenger to explode itself. This was actually the graphic design, the graphic representation of what they were using to test up to this given point. So this is the O-ring and the temperature outside of that given day, and this was given to NASA officials. NASA officials gave this to the government, and the government said, looks okay to me. The issue was, obviously, what happened was, on that day, when the Challenger actually exploded, it was actually very cold in Florida. It was around like 36 degrees, I think, at that, or 42 degrees at that given point, and that actually caused the major issue. So take this basic information of how this is how they represented it, and look at it just as a, a straight, little plot of our x-axis being Fahrenheit, and number of issues being on the y-axis here. As you can see, when it's really warm, things are okay, but it gets progressively worse and worse as temperature goes down. So if they want to give this to NASA officials or government agents, they kind of said, okay, it's going to be really cold that day, maybe we shouldn't be doing this. So there has been situations where even just representation of data can actually break this down to a point where we can have pretty major consequences. The number one question I always get when I talk a bit about visualization is, I have this data, how do I represent this data? So let me give an example. My data, I made up some random numbers here. If I wanted to represent this, maybe, I can normalize this data. So I take my largest value and I divide it through and I normalize my data. And what I get out of that, what kind of visualization would work for my data, would actually be a pie chart. Pie charts suck. Pie charts are well known to be very flawed in terms of visual representation and things of that nature. The link I gave here sort of shows some of these examples. Things like this come up where you have so many layers of different things, but you can't express them all in different colors, so I don't know where one begins and one ends. Or you have situations like this where this chart was looking at trying to say, give me their top 3 favorite pies. So how do you represent somebody giving 3 answers to sort of a breakout of 100%? And sort of where that kind of breaks apart from there. So for me, it's like there's different types of graphs that are available. Take a moment, try to look what's out there. Things like Sparklines, Treemaps, Ben Schneiderman, Edward Tufte are 2 big names out there if you're interested in learning more about visualizations in terms of different types. And even things like this, the Hive plots, star plots, and parallel coordinate plots can all represent the same data in different ways. So in this case, we're using multiple dimensions of information here, and we're showing it in 3 different ways, but representing basically sort of the same data. So when I answer this question, I usually say, if you want to know how to make a visualization for your data, first talk to your users, then your experts are going to be using this system. And I kind of already mentioned this, but Edward Tufte, one of the forerunners in terms of visualizations and graphics, looks at this idea of taking information and trying to take it in multiple dimensions of information and project it on a 2-dimensional plot, which is our screen here. So it's a very difficult task, but also at the same time up to you to sort of program for allowing that sort of action. So let's get into the D3 itself. How do you get to D3? If you don't know what D3 is first, let me just go to their website so I can show it off for a moment. D3 was developed by Mike Bostock and Jeff here, who is, Mike Bostock I think is at the New York Post right now doing visualizations for them, and Jeff here is at the University of Washington now as a faculty member. What they were trying to do was look at trying to take SVG, which I will go into a little bit more on that in a second, and make it accessible to people. As you can see, they have many examples out there. I won't be going through all of these, it would take too long, but if you're ever interested, go to their website, try out some things, and it's actually it's pretty straightforward in a lot of ways in terms of how to get some of these started. So how do you get there initially? First you need some idea of how to work with HTML and JavaScript. If you understand HTML and JavaScript, getting into things like XML and SVG kind of go hand in hand together. And finally, once you get sort of into this sort of understanding, D3 is sort of accessible at that point. So I was told to kind of prepare for every and all people, so I'm going to start at the beginning, that is HTML. To start HTML and getting D3 working, this is all you need. It is your basic HTML page where we have my head and body. The head just include their actual libraries, and you can get started from there. It's all open source, so if you're interested, you can just take a look at the source code itself too via GitHub, and that's basically how you started. So, and the first thing you need to do is actually in terms of working with this is once you have your declare script, is actually give your place for your visualization. You define a div basically, and you basically give it an ID or a class and say, I want my visualization to go here. So I already mentioned there's this world of XML that comes into play here. This was a little bit of a web history now. The HTML world, not very well formatted. Something like this, where I've removed the B for body here, changed some other things around here too. I can't remember exactly what I did with all this. This page still runs because a lot of browsers sort of allow this sort of, issues to still continue to work as is. And that's where this idea of XML came into play. XML is well formatted. And that is sort of, we have these notes, we have these opening, closing brackets, everything is lowercase, everything sort of allows you to sort of understand what you're reading. And this XML world is supposed to be a little bit more easier to read and understand in that regards. So, SVG, which stands for Scalable Vector Graphics, took advantage of this and started making sort of graphics that are available for you to design either this way, which is sort of the original way of doing this. So let me get at that example real quick. Okay, so I made a sort of triangle, made it green. This is all this is doing, this code here. Basically, you declare outside boundaries here. You declare what kind of object you're going to be utilizing. And things like this, like a polygon, obviously I'm going to have multiple sides to my polygon. And then finally some sort of style to it at that given point. As I already mentioned, this is this idea between SVG and sort of more typical canvas or pixel sort of idea. Let me show you what the major differences between these two are. This is an image that's a PNG file. Works well, very well in terms of a lot of browsers and everything like that. But the major issue comes in the fact that when you're trying to format it to a specific location on a screen, so let's say I decide to enlarge this picture. I can't go much farther into this, but as you can see, it starts to degrade after a given point in time. But with SVG graphics, what it actually utilizes is, you can kind of imagine here, an XY coordinate, and go back for a second here. On my XY coordinate, I'm going to draw these positions and make my triangle, as you remember. Well, I can do that with other shapes as well. The nice thing about this is the fact that I can zoom in as far as I want to, and nothing degrades, because all it needs to do is say, take my XY coordinate system, make it larger and larger, but I'm going to still use the same the same sort of points to actually make my object. So it's really great in terms of taking this. I have a web page that works here, but I can also now put it on my smartphone or my iPad, and it still works well because it conforms to the screen you're utilizing. So D3 has this idea of, and this is where the name comes from, data-driven documents. And it has three major things that kind of make it separated from other visualization packages. This idea of enter, update, and exit, which I'll go over in a little bit. Interactions, so you can interact with the visualization, and transitions. Again, I'll go through some of these examples as I kind of move forward from here. So what I would like to do now is just showcase the same idea that I was mentioning before. So here again, here is my SVG that I was just talking about. And how do I represent that, or actually represent that in D3? Good? Alright, so in D3, what you need to do, again, I'll keep this down here, this is the original one, is the first thing I mentioned is sort of provide a div or some sort of area that you're going to actually apply this to. You can apply it directly to the body, but usually I use a div just to kind of give a placement. D3 has a selecting system, which basically goes out to the document, finds that specific thing that you're talking about. In this case, I'm talking about a div with an ID visualization here. And now that variable viz is now sort of attached to that, so it knows that location is going to be where that stuff is going to be going. From there, all you need is actually some appends, which is basically SVG, which is the same as this. Give it a height and width, which is the same as this. And then, again, you're actually adding a polygon at this point. And at that point, you have all the same structure as the other one, but a little bit easier, I think, a little bit easier to understand in terms of formatting. So if everything goes as well, you get something like this. So here's my SVG that I was originally making, and then the new one with D3. So I was able to mimic that system. So for a simple example of D3, I made up a random data set, just 6 random numbers that I thought off the top of my head, and I want to actually start representing this information using D3. To do this, all I do is actually declare, this is all JavaScript, and all I need to do is actually declare my first array. Again, we start off the same idea as before. We select the actual div, we give it sort of that SVG box to actually put everything in, and we give it a height and width. This next step is actually starting to actually implement data. This is sort of the enter idea of the enter, exit, update idea. So from here, we select circles, which actually doesn't have any information at this given point. So we're going to give it some data, so that data is sort of where it's at. I give it circle data, which was my original array, and now I have this object that is sitting out there saying, okay, I am declaring myself as a circle, I have data, now do something with me. That's when you sort of enter this, and that the idea is sort of entering into a scene and saying, okay, for every one of these objects that I have here, so my 4, 8, 15, 16, 23, and 42, I want something to represent that in terms of appending a circle. So I'm going to have 6 circles, and for my x coordinate, my y coordinate, they're all going to be represented by each of these individual points in the array, and then the radius is going to be the same thing as well. So I should end up with 6 random circles. So at this given point, we get this, which looks pretty ugly. One of the nice things about D3 is that you can actually implement styling as well, which is something you might see with CSS and things of that nature. So in this case, I'm changing this a little bit, but I'm actually going to start implementing things like separating the circle distances by a multiple of 10, and using fill, which basically changes the color. The coloring is actually something that's kind of a nice little tool in terms of D3, in terms of they actually utilize something called an ordinal scale. Ordinal scales are basically, I could feed that in, A, B, C, D, E, F, and it would basically set up 6 or 7 different colorings that are different. I can name it apple, banana, carrot, blah, 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 and it would basically say these are all different parts of my array, and they should all be represented by different coloring. So for this, I should have 6 distinct coloring, and they utilize a category 10 or 20, which obviously includes 20 coloring, 10 uses 10 colorings, and at this point we should have something that looks a little bit more presentable. So this is what we got here. So now I've spread out the circles a little bit farther from each other, and now they all have their own distinct coloring. To actually understand in terms of how to actually work with these in terms of interactions, you can start defining functions that can actually occur when certain situations happen. So for this, I think I just typed in, I have a button. And when somebody clicks that button, it changes the nodes to my circles. And so what I want to do here is take my circle data, which is, just kind of keeping that on the screen as well, my 4, 8, 15, blah, blah, blah. And now what I'd like to do is actually start filtering on this data. And so I'm filtering basically only the even ones by using my module divide by 2 thing here. And I'm saying I just want data that's even. So now I've entered new data, now I want this data to exit from the screen. So if it's different, it should exit the screen at that given point. So now, because I'm only looking at the even data, all I should have left is 4, 8, 16, and 30. So again, for the representation, they entered into the scene. But now I'm giving it new data. So originally I had all that the circle data, but now I'm saying here's a new set of data. It's called only the evens. So it takes the differences basically between those two, and it should provide only the even ones at this given point. As you can see, it basically dropped off the last 2, which is not supposed to happen. And why is that? Because whenever it's doing sort of a data comparison, so it had my 6 points on an array, and now this is only 4 long, what it actually did was drop the last 2. You have to be specific in terms of D3 and saying, I want you to look at the values. So over here. So instead of using just the data and then giving it the actual data that we were talking about, you can actually read in a function as well. So that function basically says, based on the data, I want you to actually create these circles and remove only the odd ones. So hopefully a little bit better. Oops, sorry. So now it actually removes the evens or the odd ones and leaves the even ones there. The other thing I wanted to showcase here as well is that I no longer need these buttons that like these outside buttons. You can apply things like mouse events as well to these actual circles or anything within that actual visualization that you're interested in. So it takes all these click events, double click, mouse over, things of that nature. It allows you to utilize it. So in this case, I put on every one of my circles, I put a click event. So it's basically doing the same thing as a button, so I can click on any one of these, and it should actually interact as needed. Okay. So I already talked about adding some aesthetics here in terms of coloring and things of that nature. Entering, updating, exiting. We already talked about entering, how the data, the circles initially came on the screen. And the exit idea where it said, I'm giving it new data, so I want you to basically update that information, so sort of that overlap between the two. So there's one other thing I wanted to, I'm going to try to add some visualization aspects into this as well, like more of the cognitive psychology side as well, just because it's what I study, so I want to talk about it as well. There's this idea called change blindness. Change blindness is basically in visualization design, you want to minimize changes when it comes to one scene to the next. Because even large changes in a scene can actually be very hard to notice if they're not done within basically a smooth transition between one another. Let me give you an example of this. And what I'm going to showcase here is two images, and there's going to be a blank seat in between them. They're going to be two different images. They're going to look very similar to one another, but there's going to be one major difference between the two. And what I'd like to ask you to do is, when you're watching these, please raise your hand when you see the differences between the two pictures. We got 1, 2. So even something like that, even just putting a blank slide in between two different pictures, you're going to miss that change between them because of the fact that this change blindness sort of phenomenon. How this is taken care of in terms of Team 3 is using something called, move through this, is using transitions. It basically allows you to take one state and move to another, but in a smooth way, basically. So what I'm going to do is, so now what I can do is actually, instead of just having these disappear out of nowhere, what I can actually do is do a transition between it. So now when I click on this, I'm going to change the radius from whatever it was to 0 and have it sort of basically disappear. So in this case, again, this is the same situation as last one. Created my circle, blah, blah, blah. But this time, I'm going to when I have them exit the scene, I'm going to put a transition. And that duration here is basically that's 3 seconds, so 300 milliseconds, or 3,000 milliseconds. I want it to start at its original size, and then in 3 seconds, I want it to get down to 0, and eventually just remove itself completely. So, the last thing I kind of want to give in terms of this example itself is this is a little bit more, a little bit more encoding and stuff like that. But you can actually look at adding things like saliencies and things that allow you to actually understand that there's something here that I can click. Something as simple as mouse over events allows me to change the width size to say, I'm going to make it a different width size because now I want you to sort of understand that now these things should be clickable. Also, you can change the cursor within the style sheets as well. In this example here, I won't go over too much of the coding just because it's a little bit more in depth, but I just want to kind of get the basic idea. Is now when I select a circle, I want it to do that thing, but instead I want it to sort of pop instead. So I'm going to go through here and pop off my little circles. And eventually it'll just redraw itself at that given point. There it is. So as you can see, even taking just a small data set like that can illustrate how easy it is to take this data and make it a little bit more unique, interactive, and allow you to sort of provide a little bit of its own little personality to it. what I wanted to showcase, sorry, I have some examples going through. What I wanted to showcase was something that we actually started working on in the data visualization group. One of the things I love to do is to take data from random sources and make visualizations out of it. This is actually the Pittsburgh bus scheduling. So this is the bus schedule. And you can select nodes, and it will basically give you an idea of where the buses go around Pittsburgh. And what it allows you to do is sort of to understand how all these interconnect between one another. As you can see, I have some sort of smooth transition between each of these sort of visualizations. So you go from one state to this state to this state, and to finally a circle. Very smoothly in that regards. The nice thing about D3 is also you can do, if you go under Tools and then Developer, so under the console here, I can still work with the actual visualization even though I'm looking at as it sort of progressing over time. So I have a variable called duration amount. And this is basically that duration I was talking about before, where it was around 3 seconds. I can increase it, so let's say 10 seconds. 10 seconds. So now the duration should change for this, so if I switch to another one, it should take a little bit longer time. So now it's 10 seconds. And then I can speed it up if I want to as well. So you can do this within the browser itself, still working with the same data that I was originally looking at, and switch between these now. They're a little bit faster. Things of that nature, and you can work with the variables that you define in your actual D3 script at that point. Smooth transitions, affordances. I'm going to skip over this a little bit. I just want to talk about this scenario, and this we've already talked about in terms of with utilizing the different cursors, so you can understand that this is meant to be selected or not. This actual terminology, affordances, comes from the fact that this example here is called trap between two doors. So I'm just kind of taking a step back for a moment. Imagine we have a long hallway here. We have two sets of doors here, and this is from bad design, so obviously it's not going to go well. In this situation, the individual goes up to this first door and tries to pull it. It doesn't work, so they try to push it, and it opens the door, they walk in, and they get to the second sort of door, and they push on the door, because they expect the same thing to happen as the first door. It doesn't open. So now they turn around thinking that something's wrong, maybe something's locked, and they go to this door, they push on the door, it doesn't open because, again, this was supposed to be pushed in and not the other way around. The issue with this is the fact that they have the same door designs for each side, so you can't tell if you're supposed to push or pull. And that's the idea of affordance, is that idea that we can make something that allows an individual to understand that this is meant to be interacted with, and give them sort of the idea that this is meant to be something that can be clicked or moved or changed, transitioned, or anything like that. So adding these affordances are very key in terms of visualizations. Alright, I have my affordances here. What I'd actually like to conclude with is actually looking at some of the designs we've done in terms of visualizations. One of them was, like I already showcased here, was looking at the Port Authority buses. We put together this just to kind of illustrate, like I said, not only the network of buses within the Pittsburgh system, but how they're interconnected between each other. Utilizing the force-based diagram that D3 has already, we kind of transitioned them to different types of formats as well. Another project we were looking at as well is, I'm a big PENS fan, so I was looking at making PENS information visualizations as well. So one of the things that always bugged me was like looking at the standings for the Pittsburgh Penguins, was the fact that some teams have less games played or more games played, so it was hard for me to say, well, once they play the same amount of games, I can see who's winning, who's losing. So I built sort of a line graph that looked at sort of these differentials. So from here, this is 2 years old now at this point. But looking at sort of how the Pens won the Eastern Conference it was that year they won the Eastern Conference. How well they were doing based on potential points, which is this line up here, and their actual points at that given point. So just again, sort of looking at taking visual information from NHL.com and just making a visual representation out of it. What I'd like to do, if all possible, is maybe just type a few questions if you have anything about in terms of D3. I highly recommend if you do want to start working with the software itself. D3's website is actually very accessible in terms of getting a tutorial through, understanding how to work with actual data sets, and even one of the ones I utilize a lot in terms of my designs, because I do networking graphs, the four-space diagram, which is just fun to play with sometimes. Not a lot of code, and that's sort of the idea. So for the four-space diagram, bring that in a little bit more. Coloring we talked about, you'd actually define the four-space sort of algorithm, which only requires this much spacing, and then all you actually do is define links and nodes, which is what you see on there. So this is all you need basically to get started with this type of visualization. Very easy, and I think very accessible in that regards. And you can start plotting information that you might be interested in. So this is looking at Les Miserables, the data set where co-occurrences of people within a scene and their connection between them. And that's visualized here, but you can make a lot of different visualizations out of the four-space diagram. So again, I'd like to open this up to questions if anybody has anything, and I very much appreciate giving this talk and look forward to speaking with you more afterwards as well. Yes?
Are there any patterns or other existing frameworks that D3 is meant to work with or works well with?
You mean like data patterns in terms of like, do you mean like just the types of, the data that's out there? It's one of the best ones in terms of, like I said, the four-space diagram one is actually one of the best ones I've seen, because they actually do a lot of the layout algorithm. You can actually visualize up to 3,000 nodes and about 8,000 edges on a given web page, browser, which is wonderful to have in that regards. I would hate to actually put D3 into a specific thing in terms of what it can represent. Actually, I kind of skimmed over top of this, but jump. There's actually a big list of D3 examples. They have over 1,000 plus at this point in terms of what you can actually look at and visualize. So the only thing I can say it's limited by is actually it doesn't do 3D graphics. So if you're interested in that regard, you probably wouldn't want to use D3 in that regards, but if you're trying to visualize anything in the 2D dimensional realm, kind of open in terms of what you can actually do and apply to it in that regards. Is there any other questions? Yes?
Can it work with dynamically changing sets of data?
Yes, it can. So one of the things, just showcase this real quick. Obviously, when you try to log into something, it works really quickly. Awesome. There, you're still working. Excellent. Okay, so that one's a little easier. As I mentioned, I do some work for the Department of Defense, where we look at Twitter data and we try to do this in real time. So we developed, I developed this project of looking at collecting data and visualizing it in real time, Twitter data in real time. So giving it an address, I'll just go to Pittsburgh for a moment. It'll start searching in Pittsburgh and trying to collect data based on my search term Pittsburgh at this given point. So I should get some information here, and this will illustrate this transition action as well. So what it can actually do is, using those transitions in that enter, exits, update idea, it can take original data and then enter new data into the scene. So what should happen is, in a few seconds here, it'll actually go out to Twitter, collect the information again, and rebuild this network for us. In a matter of seconds, hopefully. There we go. So it handles real-time data very well in that regard, because it allows you to say, I have original data set from a couple seconds ago, I'm entering in new data, and that update range allows you to sort of continually update that visualization at that given point. So, I'm sorry, go ahead.
And you're actually using the Twitter REST API
Yes.
for this? Okay.
Yeah. All it's doing is going up to using the Twitter URL, the REST API, basically URL call, going out every 8 to 10 seconds, pulling new data, putting in a database, and then revisualizing the data at that given point. So this is real-time information going on right now in terms of what's going on in the Twitterverse. Any other questions? Yes?
Do you know of any good resources just for like data sets just to experiment with?
I don't recall. I'm sorry. I don't really have a good source for that, unfortunately. Usually, what I usually do is try to find something that inspires me to do something, and then I start crawling on the website to get that information for myself. I usually use Python of some sort. If you ever use Python, there's a library called Beautiful Soup, which is wonderful for that. Lets you go and actually crawl through that data. Unfortunately, I'm sorry, I don't have a good answer to that in that regards.
I might have a recommendation for that. I like using the public data API for the Chicago public transportation because they have GPS locators on their buses, and they serve that with a public API, and it's fun to play around with. Then I bet you could make some nice visualization about actual physical location of buses through Chicago.
Very interesting. And also the project that I was mentioning with the buses of Pittsburgh, if you go onto GitHub, I have that listed on there. I have my bus database there, so if you want the Pittsburgh bus schedule, right there, if you're interested.
There's also a ton of public, like government data. I can't think of a URL, but I just Google like open data. There's probably
There's a lot of open data gov now, and the Census Bureau. I mean, it just depends what kind of. I think like Patrick, kind of get an idea of what kind of data you want, and Google it. You'll find some open source data.
Just kidding yourself.
Or just scrape it from the site. Yeah.
I wrote one Python script to scrape the patent authority, and there it is. But yeah, so for me, it's mostly I try to find out like things that I'm interested in, and then try to see where there's data and see if I can get that data for myself.
I know like Baltimore, as a city, has an open data initiative now, where they're open sourcing all their data, so you can play around with lots of neighborhood and kind of school breakout and stuff like that. So, different cities are doing different things.
And if you're interested, I've also made very short. Do I have anything? Let's see, get scheduled. I'll put it on here as well. But even something as like with this project, they don't actually geotag or geocode their own the lat long of that bus stop there and stuff like that. Google Map API is wonderful for getting geotagged information, so I just give it a location, it spits back a lat long, and then I can just store that information as well. So even finding those other programs that strengthen the data source can be great in terms of making interesting visualizations. Any other questions? Yes.
Go ahead.
Have you personally hit any sort of practical size limit on enough data that you can visualize?
One of the other major drawbacks of D3 is because it's browser-based. It depends. On my laptop here, which sucks, I've hit limitations, but I have my computer at home, which is a little bit better. The browser handle is a little bit better in that regards. There are a lot of limitations when it comes to browsers, so even something like this visualization here, it utilizes, there's about 122 stops in Pittsburgh, and there's 300 some different connections between them. Even something like this is handled very, very well. In D3 you can actually do maps as well. So this map behind here is a D3 map. That's where I find a lot of limitations come into play because of basically all these are little polygons and they're very intricate and there are a lot of points to them. I wonder if I can showcase that in that regards. So I don't want to say there's a limitation in terms of that, but you do have to be sort of aware that, who's utilizing this, what kind of bandwidth speed are they going to be utilizing in terms of the web browser in that regards. I usually don't find anything too difficult in terms of how much I can visualize. Major issues I usually have in this regard are with the force-based diagram because of the fact that there's actually an algorithm in the background that's updating this. So once I get too many nodes or edges, it actually stops working so well. But the amount of information here, let me just showcase what I have on this screen alone. So my graph, it's buried apparently.